Hello everybody, and welcome back to the next episode of this series. In this episode we are going to be putting animations in for our character. So let's go ahead and get our animations in. Now I was making some sprites earlier in ASprite, and so I have a simple little run cycle, an idle didn't have time to do an animation for that, and a crouch. So let's get this in. So there are multiple ways you can do this. One of them is that you could export your sprites one by one. So rather than as a GIF, if you did .png, then when you export them, it'll do all the frames, right? And then you could one by one slot them in. But that creates a bunch of files, and that is a little bit slower, and it's a little bit tougher because then you have all these files to manage, and you have to remember the way you name them and all that. So instead, what many game developers opt to do is something called a sprite sheet. So ASprite is great because it has this built in. So if I go to File, Export Sprite Sheet, you'll see that I can export all my animations in one image. And you can play around with the layout of it. So one thing I like to do is split tags. So this is my idle animation, and see, like, if I wanted to add more frames, I could do so without disturbing the placement of the other ones because they would go next to it. Same thing for the crouch animation. And I left some empty frames, enjoy the disembodied head, so that way, you know, in the future, if I wanted to expand that, I could add more frames down here as well. So I always like to do split tags. And then and even if you had layers, you could split those as well. And here you can control frames, all that. But I'm going to go ahead and output this file as raccoon.png in the assets folder of my game. Now if I look in my assets folder here in Godot, you'll notice that I have this new file, and if I drag that in, you can just see it in the game. If I zoom in here, you'll notice that it's pretty blurry though. The reason for this is that by default, Godot filters all these images with a little bit of blur, so that way there's not super clean pixels, and so that way you're not looking at an image and counting each individual pixel. But we're making a game with pixel art here, so if you're doing that, what you're going to need to do is go to Project Settings, and then you're going to want to go to General, and then down to Rendering and Textures, and change the default texture filter from linear to nearest. And if you do that, you'll notice that these are fixed now, which is great. So I'm going to go ahead and just delete that node because we don't want a sprite node. Today's lesson is about AnimatedSprite2Ds. So let's go ahead and get that going. So here's our character, right? Right now just our little bean, but we want to fix that. So what I'm going to do is I'm going to click on the character body 2D. And by the way, you can rename all these nodes. So I'm going to double click on this, and I'm going to rename it to Raccoon. So I want to add my sprite as a child of this node. So that way when the node moves, the sprite will move as well. So with Raccoon clicked, or with your character clicked, we're going to click Add Child Node. And here we're going to search AnimatedSprite2D. This is a sprite node with multiple textures, and it automatically has a system built in for animation. There's multiple ways to do animations. For something with frames, I highly recommend using an AnimatedSprite2D. So here we'll notice we have a little error, so let's read it. A sprite frames resource must be created. So the way you do that is over here on the right. If you click this little drop down for animation, you'll see our sprite frames are empty. So what we're going to do is we're going to click here and create a new sprite frames. Now if we click in again, we can edit the sprite frames, and we get this new little window down here. So here is the AnimatedSprite2D sprite frame menu. So you'll notice on the left here, this is the list of all our animations, and then this is where our frames will be. So let's go ahead and just double click on this default, and let's create a new animation name. So let's do idle. And whether or not it's caps or not is important later, so just make sure you pay attention to whether or not the exact spelling you use here. So we can click this little icon up here to create a new animation. Let's call this one crouch, and let's create one more called walk. So these are all the animations I have so far. If you have more, you can put them in. And actually, I'm gonna create another animation just from the middle of the one I already have called airtime. And so let's do this. So if I click walk, because I want to import my walk animations, you'll see here we have these different buttons. Because I'm using a sprite sheet, I'm going to use this one. What you could do is add frame from file, and if you do it this way, then it'll add each image one by one like I was talking about earlier. But what I'm doing is I'm adding a sprite sheet, and so if I click this little grid here, and then I go and I select my sprite sheet, you'll notice there are these lines, and so each of these is actually a sprite, which is great. So here we can see that it currently thinks that we have 4 by 4 sprites, but that's not the case. We have 6 by, 7? So what I'm going to do here is on the top right, you can choose how many horizontal frames you have. So I believe, it's 6 by 6. So if I do 6 there for horizontal, we have 6 horizontal frames, and then 6 vertical frames, and everything lines up. So because I'm doing my walk animation, if I click, I can add one by one all my animations. And actually you can click and shift click as well to add a bunch. So now if I click down here and add frames, they're in here. And if I click the little play button down here, it'll begin to play. Now this isn't the right frames per second. I want my raccoon to not run in slow motion. So here we can adjust the frames per second of the animation. You can also do fun stuff like click on this animation and you could click this and make it last for longer if you wanted. But I want all my frames to be the same duration, and I want them to run faster. So rather than running at 5 frames per second, let's do something like 10. That looks better. Maybe even 12. Yeah, that looks pretty smooth. Now I'll go in and add my other frames. So in the idle, I only have a static image for this one. This is a little bit frustrating. Sometimes it doesn't remember when you've already made when you've already added frames from an image. It doesn't remember the size, so you might have to manually redefine each time you add, which is a little frustrating, but it works. So I'll add each of my animations here. And this is my airtime. I'm just going to use a frame from my running cycle as my airtime for now. And so now we have our animations in. So now that the way that we're actually going to control what animation is playing is through our script, and that's actually pretty easy. So what I like to do is I often like to create a separate function just for handling animations, and this is something I recommend you do as well, because it makes it a lot simpler to group your sort of ideas. So what we'll do is, before we well, you can put this wherever you like. I like to always call my functions at the top of physics process delta. So every single frame, everything under here will happen. And so what we can actually do is put a call to this function, right? So this is the function, and here I'm just calling it. Because physics process delta is being called every frame, the animate function is being called every frame as well. Before we start typing down here and putting in our code for the animation, let's put a reference to this node. So here's how that works. What we can do is we can type @onReady, and you don't have to understand why we need that. Just know that for references you should have that. And here we're going to type AnimatedSprite. This is just a name I'm going to call it. And here we can do equals, and we're going to set this variable, which is actually just a reference to our node, equal to, you do $, and you type it will be whatever the name of this node is here. So if I were to call this to raccoon sprite or whatever, the way that this works is that this $ means it's a child. So the script is on the raccoon, so $, and then if I put $raccoon sprite2D, it's a reference here to its child. So rather than typing this out every single time, I can just type this out. And that's great because let's say later on I need to rearrange things or have this be a child of something else. I can just edit it here rather than having to edit every single time I reference it in code. So let's go ahead and come down to animate and let's begin putting in some of the logic. So the first thing I know for sure is that if our character is on the floor, I want our animated sprite to play idle. So this is how you would type it out. But I only want it to play this sprite, this animation, if our character is not moving. So the other way I can ensure that is if our character is on the floor, and what I like to do here is do input vector.x equals, you do 2 equal signs when you're checking if something is equal versus setting it. So you'll notice here we use 1 equal sign to set a variable, but we use 2 equal signs here to check a variable. So if we're on the floor and we don't have an x input, play idle. Let's go ahead and separate these out to be a little bit easier to follow. So this isn't necessarily the most optimal way to write the code, but it'll be the most easy to understand. So here we have, if our character is on floor, and if our character, if we're not moving at all, play idle. Else, so if our character is moving, we want to play animation sprite walk, right? But if we're not on the floor, and so here we use else. If we had another conditional statement like is in the air, which is redundant, then we would use else if. But in this case, we're just typing sort of the opposite. So we're not on the floor, then animation sprite dot play airtime. So let's go ahead and test this out. So I'll run the game. Our character moves. Now if we jump, see it's that freeze frame, and our character is animated. But you'll notice a couple things. One, our character is very small, and two, it doesn't change direction. So the first fix for that is that because we imported pixel art that was exported at a 1-to-1 scale, each pixel is actually 1 pixel. And so I always scale up my pixel art in my game. There are 2 ways you can do pixel art. You can do it the modern way, where you scale it up, and so then you have pixels that don't totally align to the grid, but it's still the aesthetic of pixel art. Or you can actually shrink down your resolution and run the game at a lower resolution and just increase the size of the window when you play the game. I always prefer the modern solution because it gives you a lot more flexibility, and it still captures the spirit of pixel art without being totally bound by it. And so you can get some fun things, like you can actually do rotations and stuff without it looking too horrible. So the way we can do the modern style is we click on our animated sprite, and I'm just going to scale it up. For a typical game, I like to do a scale of 3 times, something like that. Though actually, let's run this. Is that gigantic? Yeah, that's pretty big. So let's check what resolution our game is actually running at. So if we come up here to project and project settings, and then we go to display window, we can see our viewport height. And so this is viewport width and height. And this is actually the resolution our game is running at. It's kind of a strange set of numbers. I'm not really sure why it picked that. So let's go ahead and just change it to something more classic, like a 1280 by 720. And so once we did that, you'll notice that this little purple window here changed size. So it's a lot bigger now. Yeah, so this is still pretty big. So I'm going to just go ahead and change this. So rather than doing a scale of 3, let's do a scale of 2. And let's run the game and see how that looks. Yeah, that looks better. I think I like that size. This is a decently big sprite, so that's probably why we need a lower scale. My character is about 32 pixels high, a little bit wider. So that looks good to me. What we're going to need to do next is make sure that the collision sprite is correct for the character's size. So I'm going to click on my animation sprite and I'm going to change it to just sort of an idle animation. And let's make sure the collision is good. So here our collision shape is actually behind the sprite. To make it easier to see, I'm going to click and drag and bring it below the animation sprite. So the way that it works here in this scene list is anything that is below something else will appear on top. So because this collision shape is below our animation sprite, it'll appear higher, and so like in terms of layers. So let's go ahead and let's drag this around to get it to fit. I think I want to move my sprite up a little bit in terms of height, just so it's a little bit more centered. So I'm going to do negative, I don't know, 4 or something. Yeah. And so we can really zoom in here and see, yeah, that looks like it's about lined up. And that height looks pretty good for my character. And it looks a little, I think I can make my capsule a little bit wider, because otherwise my character can run a little too close to the wall. So my guy is kind of friend shaped, kind of spherical. But let's go ahead and test this out now. It's looking pretty good. Character can run into walls. Now that we actually have a sprite for our character, I like to click this little eye button over here next to it and turn off the visibility of that collision shape, so that way I don't have to see that ugly collision shape when I actually play the game. So great. So we have our size fixed, we have our the collision shape fixed. So now let's make our character change directions. So if we're on the floor and we're not and our input vector isn't 0, so that means we're trying to walk, then we play animation.play.walk. But we need to fix the scale so that way it faces the way that we're walking. So we actually have a variable showing which way we're walking, and that is our input vector.x, right? So what we can do is we can set our animation.sprite. Well, there's multiple ways you can do it. There's straight up a flip h property that we can just flip, right? Another way you can do it is you could also make it have a negative scale, right? Well, I flipped it both ways, but you could do that as well. I've done that in the past. There's something to think about is that if you were using a joystick, you might have numbers for your input vector that aren't exactly binary. It could, instead of it being 1 and 0, it could be 0.8, and so then you could get weird things with your character changing in size horizontally. So we don't want that. So we're going to use the flip h property. So what's great about this system is that if you click on any node, you can see the properties that you can edit with code. So if I want to edit this flip h property, if I hover over it, you see the name that it's called in the script. So this is the flip_h property. So that's what we can adjust. So dot flip h, right? And so if we hover over it, it says if true, texture is flipped horizontally. So let's create a little system here. So if input vector.x is greater than 0, then I want to set AnimatedSprite.flip _h to false. Otherwise, if we're moving to the left, I want our AnimatedSprite.flip _h to be true. So let's test that out. So our character now flips direction. And what's great is that even if we hold left and then we stop, our character stays facing the other direction because the last input it had was that way. I'm realizing we didn't add my crouch animation, so I'm just going to do that. You might not have one. So we definitely want it to happen when we're on the floor. That's right. We want it to happen when we're not walking, but we want it to happen if we're holding down. So the way we'll do that is we'll put it here at the top and do if input vector dot y is greater than 0, because remember, downwards is positive. We want to play animation.play sprite crouch. We want to do our idle animation if that's not the case. So I just hit save, Control S. I'll run the scene again. If I hold down, I do a little crouch. So now I'm probably going to tweak this code. I'm probably going to make it feel just a little bit better. So I'm going to go ahead and do that now, adjust the speed and such. So yeah, we've successfully created our little animation sprite character. So he's animated and he moves around. And you can get more complicated with this and do things where, like, if the character is moving up, it has a different animation than if the character is moving down. You can do idle animations and more. But this is it. It's not too complicated, right? Thank you guys for watching, and see you in the next one.